Right. So let's go to your next part of this question. It says to us here, we need to determine dy over dx if something is very interesting. Now, you will notice something very interesting with the next question. It says to us, find dy divided by dx, right? If y is equals to 12x squared plus 2x plus 1, where everything is divided by 6x, right? Now here, I was not told what to use, right? I was not told what to use. There was no technique that I was forced to use, so I can apply the rules of differentiation, which means I'm going to apply the power rule here, right? Now, why do you guys suffer or struggle in differential calculus? It's not because you don't understand how to derive. You are always challenged by the algebra part of what you're looking at here. Now, in order to find the derivative of y with respect to x, what I'm simply going to do here, I'm going to first of all do two things. One, make sure, right, all terms, right, are in the form, a very beautiful form, coefficient, base, exponent. There must be coefficient, right, and then you must have times the base, and you need an exponent there, right? They need to take that form, which means, what do I mean? They need to all take the form something x to the power of some exponent. That's how they need to all look. If they don't look like this, then you can't find the derivative. That's the first thing that you need to do. And then when you derive, you're of course going to do the following. This is how you're going to find the derivative. You are going to multiply to derive. When you're deriving, right, to derive, you're going to multiply the coefficient and the exponent. So you're simply going to have n multiplied by a, right, x to the power of, on your exponent, you're going to just subtract 1. That's essentially what you're going to do. It's as easy as that, no complications. This is so easy, even a grade 8 learner can be able to follow the argument. If somebody gives me y equals to 5x cubed minus 4x squared and ask me to find dy over dx, what I'm simply going to do, I just multiply the exponent and the coefficient. So it's going to be 3 times 5, which is going to give you 15. X to the power of, on the exponent, you always subtract 1. You're going to get 2. And then the next one is going to be negative 4 multiplied by 2. Exponent times coefficient, which will give you minus 8. X to the power of the exponent minus 1, which is going to give you 1. So you just simply keep doing that over and over and over again until the second coming. You will always get your answer correctly without any challenges, right? Okay, cool. So now what I'm going to do is I'm going to go back to that question that you gave me and make sure, first of all, that everything is in the form coefficient, base, exponent, and then I'm going to find the derivative of y with respect to x, right? So I know some of you guys might be worried with the notation that we're dealing with here. We'll keep explaining to you what do you need to do when we're talking about different ways of finding the derivatives. So let's start with simplifying it. I don't like the way it looks. I need to make it coefficient, base, exponent. So let's write it down. So we are given here that y is equals to, right, y is equal to 12x to the power of 2 plus 2x and plus 1. Everything must be divided by 6x. So from here, let's fix this. I'm going to apply a very beautiful principle which comes from straight from algebra that says if you have a plus b divided by c, you can give each one of the stuff on the numerator its own denominator, which means that can be re-expressed as a over c plus b over c. So that's essentially what I'm going to do with my 6x. Please be careful with this, right? So I'm going to say, okay, this can be written as 12x squared over 6x plus 2x over 6x plus 1 over 6x. That's the idea I'm applying here, right? And then we're going to start dividing, right? Now remember to also be good with your laws of exponents. This is actually where the problem lies when you're doing the power rule and all that. Your ability to use your laws of exponents is what causes you problems. So 12 divided by 6, beautiful people, is going to give me 2. Now x squared divided by x, it's top exponent minus bottom exponent. So on the numerator, my exponent is 2, on the denominator it's 1. So 2 minus 1 is going to give me 1, so I'm going to get x to the power of 1 as my exponent. I don't need to write it, but I'm just writing it explicitly so you guys can see I did 2 minus 1. Laws of exponents, very beautiful and important power of skill. Right, now on these ones, x and x will simply cancel out. I'm just sitting with 2 over 6, which is going to give me a value of exactly 1 over 3, right? And on the last one, now here is a big problem. Now you people can actually check the stuff we write on the notes and the things we give you on the textbooks and all that. Most of you know that when somebody asks you to derive a situation where you are left with maybe say 4 over x squared, you would need to take this x to the numerator, right? You will basically say y is 4x to the power of minus 2 because you want it to be coefficient base exponent, like I said, right? So you move this x squared to the numerator, and every time you move something from denominator to the numerator, the sign of the exponent is going to change. And this is from grade 11 and grade 10 swag. Very beautiful stuff. In fact, it's from as way back as grade 9, right? Now, when you faced with a problem like the one I'm currently sitting with, where I've got 1 over 6x, right? Stay away from the 6. Do not touch 6. We are interested in the variable that we are deriving with respect to. We are interested in the x. So only move x alone. Leave your coefficient as 1 over 6. Move x up. The current exponent on x is 1. It is going to be x to the power of minus 1 when it moves up, right? Now I'm ready to find the derivative. Remember, when you're deriving, you can't derive in parts. You derive simultaneously, which means you derive everything at once, right? Okay, cool. So let's see what the derivative is going to be, because now I'm ready to find the derivative. I'm going to say to the examiner, I'm now deriving. So I indicate by writing now dy over dx, which says what you're about to see is the derivative of this function that you gave me. It's going to be the exponent times the coefficient. So 1 times 2 is going to give us 2. X to the power of 1 minus 1, which is going to give us a value of 0. I don't need to write that. I'm just writing it for the benefit of those who are watching the program for the first time, right? And then I'm going now to go to the next one. Then the next one is a constant. And most of you know that the derivative of a constant will always be 0. So the derivative of 1 over 3 is just going to be 0, which I don't need to write, but I'm just going to write it for the benefit of those who are watching the program for the first time. You don't need to derive this. You just need to know that the derivative of a constant is always 0. I can hear somebody shouting somewhere from that, but why is the derivative of a constant equal to 0? Well, we can actually explain it like this. Imagine if I have y is 1 over 3, right? Which means 1 over 3 can obviously be re-expressed as 1 over 3 times 1, all right? It's the same thing, so which means this is y is 1 over 3 times, but 1 is a special number. You can write it as x to the power of 0, because anything raised to the power of 0 is 1 except 0 to the power of 0. And then if you now do the derivatives by doing dy over dx, which is exponent times coefficient, 0 times 1 over 3 is going to give you 0. X to the power of exponent minus 1 will give you 0 minus 1, which is actually minus 1. But 0 times anything will always amount to 0. So this is the reason why the derivative of any constant will always be 0. We can actually use this idea to explain to you that the mathematics is consistent. It does actually explain why the derivative of any number that is a constant will always become 0. Right. Now on the next one, I've got minus 1 times 1 over 6, which is going to give me a value of negative 1 over 6. So let me remove the sign and fix it to a minus. So I'm going to have minus 1 over 6 x to the power of minus 1 minus 1 will give you minus 2. Please be careful when you're dealing with negative exponents. We are subtracting 1. You're subtracting 1 on minus 1. You will get minus 2. Please be careful of that. Beautiful stuff. Now I'm ready to actually re-express this in a nicer way. X to the power 0 is 1 on the first term, so I'm just going to end up with 2. 0 is nothing. I'm not rewriting that. So what I'm doing is I'm going to take back this x to the power minus 2 back to the denominator, because we don't like negative exponents. So it's going to move from where it is to go and join 6, because what you're essentially working with is it is currently on the numerator. So you are going to move it to the denominator. When you're moving stuff from numerator to denominator, what changes is the sign of the exponent all the time. So my x is currently minus 2. When I move it from where it is to the denominator, it's going to be plus 2. Please keep that in mind, right? So this is going to be minus 1 over, right? Let's keep the consistency of column. 1 over 6 x to the power of plus 2. And this will be your dy over dx, right? So I hope this actually helps you to understand what you had to do. We're still coming back, guys, with a lot of very exciting questions. This was just the basic part that explains to you what is calculus. Calculus is this. Anything you're going to see beyond this is no longer calculus.